one is in degrees, this one is in radians. Okay? 360 is what? Who class? 2 pi, right? 90 pi over 2. Very good. Okay, what about 30? Yes, pi over 6. 45 pi over 4. Everybody okay? Now, what about 270? This was yesterday, that one. What is it? 3 pi over 2, right? Everybody okay? Alright, now, the special angles, okay, also includes 60. What is 60? Pi over 3. Okay? Then I told you, these special angles, you must know the exact form type. Now, because we can use a calculator, we can use a calculator to check. Remember I told you this? Okay, now, I'm going to revise this from yesterday. This is an isosceles triangle. Just this is one line. Okay, this will be what? 45. Now this one is yellow. Yesterday I explained already, right? So sine 45, cosine 45, and tangent 45. Of course, we still use so sine is 1 over root 2, cosine is 1 over root 2, tangent is 1, right? Am I right to say that? Now this is when we write it in what? Degree form. Now, if I write it in radians form, it will be sine pi over 4, right? Equals to 1 over root 2. Cosine pi over 4 is 1 over root 2. And tangent pi over 4 is 1. It's the same thing. Just that I write this is equivalent to this, just like from here. Everybody clear?
Yes.
Okay. Now, then we go on to the next one. If these three sides are equal, like what Daniel said yesterday, this is called an equilateral triangle. Okay. Now, let's say this is 2, 2, 2. So if I divide it into half, this will be 90. This is 60, 60, right? How much is yours? 30, right? Then I say, if these two sides are equal, I draw a triangle, these two will be divided right into the same. Then I say, I don't need to use the whole triangle. I only need to use this one, right? Now, this one will be what? Root 3, right? Remember yesterday we said, how do I get root 3? 2 square minus 1 square and square root, right? Minus lah. This is the hyperma. Okay, so 4 minus 1, so it's root 3. Everybody okay? Alright, so now we can have 2 kinds. Now, can I leave the radian one for you to write yourself? I just do the degrees one. Okay, sine 60, cosine 60, and tangent 60. What will it be? Sine 60. Root 3. Are you what am I writing? This is rubbish. Root 3 over 2. Cosine. Half, right?
Yes.
Tangent. Root 3 over 1 is just root 3, right? Now, if I want to write in radians form, this one will become what? Pi over 3. Okay? Now, then we also have sine 30, cosine 30, and tangent 30. Sine will be what? Root 3 over, okay, what am I doing? 30, right? See what will be? What's that? 1 over 2. Cosine? Root 3 over 2, right? How about tangent? Tangent. 1 over root 3. Is it correct? Opposite over adjacent. Okay, now if I want to replace by radians, what will this become? Pi over 6. Everybody clear? So I want you to get used to the radian degree concept first. They are equivalent, and we'll use it interchangeably in the question itself. Okay, and what's more is that this radian thing will happen again in chapter 8 of your EMATS. Okay, and radians, if it is special angles, of course we can put it in terms of pi. If it's not special angles, then the angle can be angle equals to, let's say, 1.2. Like that. When I say angle equals to 1.2, that means what? Angle equals to 1.2 radians. Understand? You just know that it's equivalent. Okay. Now, then I need to go to the calculator for some other things. Now, some people are confused as to when do we use degree mode, when do we use radian mode. Am I right? Okay. Now, let me just make this clear once and for all. Because students are always like confused. I get very angry. And I also very angry at people talk in the class. Don't need to explain to you. You don't know, you ask me later. Okay, don't distract me. Now, when do we use degree and radian? Where must we change it? When the expression is, let's say, half times 4 times 5. Can you see there's no sine or cosine? Then any mode also doesn't matter. The answer will come. Understand? It's just numbers. Do you understand? But if let's say I have half times 4 times 5 times sine 75, let's say degrees, then you must change the calculator to what? Degree modes, because I'm taking sine 75 degrees. If not, if you don't change, you go to the wrong mode, you'll give the wrong answer. Do you understand what I'm talking about? Yeah. Okay, now, what if I have half times 4 times 5 times sine, let's say 1.3. This one means what? Radians, right? That's why I say it's very important whether you know degrees or not. Okay? So once I have this, can you still put it in degree mode? Cannot. You must put it in radian mode because this is sine 1.3 and this is in radians. So the degree and the radian mode you must only change when you see sine, cosine, tangent. Understand? And look at the angle. Is it in degrees? If it's in degrees, change to degree mode. If it's radian, change to radian mode. But if it's just numbers, any mode will do. Do you get what I'm talking about? I'm making myself clearer. Yes or no? Now, when I'm going through the example, I'll remind you again. Because I told you right, there was one student. Throughout the exam, the calculator was in radian mode. And he's taking Emacs. You know Emacs angles always in degrees, right? Usually in degrees. Okay, only chapter 8 that part, then that's radians. The whole paper, he got the correct answer, but the answer is all wrong. It's only given method part. Not talking about. Because it's in the wrong mode. Okay? What's first? You are in the radian mode for Emacs. And Emacs can switch between two modes. Am I understand that? Okay? And then this person also, the whole thing was in radian mode when the thing was in degrees. Again, the marks were gone. Okay, so you have to be very careful. Do you understand? So do you know when to use degree mode, when to use radian mode? Yes. So when it comes to what? Sine, cosine, or tangent. Okay, look at the question itself. Okay? Alright, now there's one thing that is very irritating when we are marking. Now, when the question gives you in radians, like that, right? Do it in radian mode and then get the answer straight. Some people like to convert from radian to degrees. Then use the degree mode. Now, you're giving yourself trouble because why? You will convert wrongly. You don't understand what I'm talking about. If there's a mode for you to change, why don't you just change the mode? Do you understand? I know you're comfortable with degrees, but it will be a mistake. It doesn't matter. Next time you go up to JC, there will be even polar coordinates. Okay? Not just Cartesian like X, Y. Polar coordinates means a point, you know, when it's a point now, we have X coordinate, Y coordinate, right? In polar coordinates, we can identify a point by the length of the circle. You see this one will become a circle. This is the center. I can represent by the length of this, right? With the angle it makes with the x-axis. I can also identify a point. For example, I say R is 4, that means 4 cm, or 4 units. Then this theta is 45. You can see that I can also identify the point. Where is the particular point? So this is called polar coordinates. When you go to JC, if you want to do maths and then you will know all this, alright? Okay, okay? Alright. It's not polar bear. It's called polar coordinates. Alright? Okay, now, then we can go on to the textbook. Can we turn to page 274? Okay, page 274. Now, the activity 11A on page 274, I've already derived for you on the board. Can you see it? Yes or no? Okay, you can go and derive it yourself again. Will that be okay? Try and derive, because in the exam, nobody's going to draw a triangle for you. Everybody clear? Okay? Alright, now let's look at example 1 now. Okay? This first section is very easy because it just shows some relationships and we're going to do the questions now. Okay? Let's look at example 1. Loading. Okay? To facilitate loading, an inclined plane is set up as shown in the diagram. Okay, now I'm just going to draw that triangle. I'm not going to draw the lorry, okay? Don't laugh. Because some people, right, when they're desperate in exam, don't know how to do, right? They insist on drawing the lorry because at least they feel safer than there's no my friend and it's nice. It's not a hard exam, understand? Okay. Alright, let's take a look. To facilitate loading, an inclined plane is set up as shown in the diagram. Now, if friction is ignored, what do you mean by friction is ignored? You assume no friction now, so there's no resistance force. Is that clear? Okay. The time t seconds taken for a block to slide down the inclined plane is given by the equation. Okay. T equals to square root 2a over what? G sine theta cosine theta. Where a is in meters, okay, is the length of the base and g is meter per second squared is the acceleration of gravity. Have you done G in your physics?
Yes.
And G is, approximately 10, so it's 9.8. Okay, G is approximately 10. That is the gravity acceleration. Okay, alright? Without using a calculator, find the exact value of T in. Okay, now this is your A. Alright? Then so on and so forth. Now let's look at part 1. Without using a calculator, usually if you want to test whether you know or not, you say without using a calculator, find the exact value. I want to warn you, if exam say find the exact value, you cannot give it in decimal. If the thing itself, whole thing is like root 3, root 2, that kind of thing. Do you understand? Okay, I will show you now. Okay, now they say that A is 5, G is 10, and theta is 45 degrees. Okay, now let's do the 45 degrees over here first. Let's practice. 1, 1, focus. Okay. What is sine 45? 1 over root 2. Cosine 45. 1 over root 2. Tangent 45. 1. Now, tangent 45, 1 must be memorized. Because when you draw graph later, you must know this also. Okay. Now, then we just plug in. T will be square root of what? 2 into 5, right? Over what? 10. Then I have sine 45, cosine 45. You know how to say that? Okay. So this will be square root what? 10 over 10, right? What's sine 45? 1 over root 2, and then 1 over root 2, right? Now, do you agree this one cancels off? So this one becomes square root of what? 1 over 2, right? For your cert, 1 times 1 is what? 2 times 2 is 2, right? Okay, so this one becomes square root of 2, correct now? Yes or no? Square root of 2. So you look at the answer on the next page, can you see you get square root of 2? Is everyone okay? Alright, now the second part, I'm not going to do it. Part 2, they say A is this value, G is 10, and theta is 30. Now look at the solution. Can you see that they just plug in the number and then you simplify? Can you see that they give it in cert form? Yes or no? So this is just some manipulation. Are you all okay? Right? Okay, good. Now next, example 2. This one later I'm going to show you something also because Emacs also will use it. Okay, now let's take a look at this one. Example 2. This is 90. P, Q, A, theta, B. 90 minus theta, C. And this is my R. Now, I just want to tell you this that is very important. All look up here, please. If I have a triangle and this is 90, let's say this is X. Or it can be theta, anything. Do you agree that this is 90 degrees minus X? Everybody okay? Cannot. You must know all this, if not it's very troublesome. No? Then I want to extend this further, because this one, O level sometimes they will give, and then some students they don't know what is happening on earth, right? Okay, I'm going to show you this. Because this one came up in O level last year, students cannot see that here. Now, this is 90. Okay? Everybody okay? This is theta. This whole thing is also 90. This is what they gave. Actually, it's on similar triangles. Okay, but I want you to know how to identify the angles first. On that, everybody listen, this is important. If this is 90, this is theta, do you agree that this is 90 minus theta? Is everyone clear? Okay. Now, this whole thing is 90. If this is 90 minus theta, can you tell me what is this? Do you agree this is theta? What? Am I right to say that? Correct? Yes or no? Because these two add up together must be 90, so must be like that, right? Agree or not? Yeah, because you know guys don't miss it, they will die, I don't know how to do that off-rated. Okay, then I want to ask. This one is straight up, so 90. So what is this? 90 minus theta. You must know all this. You cannot say, I never learned before in my whole life. So this is theta, this is 90 minus theta. This one I don't know, die. But you must know this is 90. Therefore, this one is 90 minus theta. This one must be theta, right? Agree or not? So you must know all this. Do you understand? Nobody will tell you, you must know one. Understand? This is common algebra, okay? Very basic algebra, okay? Can or not? I want to tell this to why class. Hope that this class will really do well for the next time. AE Maths. Nobody is going to drop anything. E-Maths certainly cannot drop. It can drop, I think those schools should drop. Then I will go to another place and teach you. But A-Maths, right? Also hope that you will not drop. Because you really need it for future like H2 Maths or even if you are doing some Maths related areas discipline. Is that clear? But I know some people they really cannot stand Maths. It's okay. It doesn't mean that I want to love Maths. I never say love Maths. I say obtain the results that go to the course that you want. Is that clear? And next will give you a lot more options. Is that understood? Okay, now next. Let's take a look at number 1. Very good. This one clear already? Yeah. Clear, Okay, good. Okay. First one. Show that tangent 90 minus theta is equals to 1 over tangent theta. They say show, don't go and say equal. Rubbish, This is called right hand side. This is called what? Okay, rubbish. This is called left hand side. This is called right hand side. And in Maths, left hand side is like that. Right hand side is like that. Okay, don't say what? This is some alien language. Okay. Now, let's do this. Usually we prove from one side to another side. Understand? Because later we're going to do proving. This is what it is. Okay, tangent 90 minus theta will be this one, right? Do you agree? It will be this one. Tangent of this, okay, I write for class here so that you see better. Tangent will be A over B. This is A over B. Alright? Yes or no? Yeah. Okay. What is tangent theta? B over A, right? Alright. Now, if I take 1 over tangent theta, what will happen? I will flip this thing, right? Alright. A over B. Now, can you see this and this same already? Can you see these two same already? Yes or no? Yeah. So, therefore, tangent 90 minus theta will be equal to 1 over tangent theta. What does it mean? What does it mean? Some people when they see this, right, you want me to put this for what, right? Rubbish, right? That means tangent 40 degrees must be 1 over tangent 1. 80, okay. This is 90 minus theta, right? What must be this? Will be 50, right? These two are complementary, correct? Complementary means they add up to what? They add up to 90 degrees. Can you press your calculator for me? Tangent 40. Everybody go and press tangent 40. Tangent 60 is 1 over tangent what?
70.
Why 70?
Plus 1.
Oh, plus 1 your head. I said this one and this one add up to 90. This one and this one add up to 90.
Ah, okay.
What? Yo. Hey, you see that? I write nonsense, right? 30 degrees, correct ah?
Yeah.
Press. Tangent 60. And 1 over tangent 30. What is it? Is it the same?
Yeah.
Is it the same? Yes. Okay. You get the third one more, right? You should sit outside the class.
Tangent 55.
Huh?
55.
What's this?
55.
55. Very good. Finally you understood. Then tangent theta is 1 over tangent what?
90 minus theta.
90 degrees minus theta. Correct ah? Now it doesn't mean that like that work like that no work is the same You not tell me no. Textbook say how must like this. Like this about it not same logic talking about now, ladies and gentlemen. The two angle add up to what? 90. That's all done. Everybody okay? Okay Clear already the first one?
Yeah.
Okay, second one now. Wow, this shot I really like your reasoning Last one. So if it's 30 then 40 lah. Last
Yeah,
one.
that's what I thought so.
Then if it's 44, 54 lah. You see, you cannot answer me any right? That is your
Yeah, really, I thought it was.
I think you are out of your mind, that's all. Okay. Wow. Do you know that this kind of reasoning has never crossed my mind in my entire life? Somebody will tell me this and I'm enlightened. Okay, just like that time I told you right. A plus B2 over A plus B simplify become what?
A plus
A plus B, right? The student tell me the answer is square. Then I say how you write the square, you tell me. Then you got no answer from here. I don't know what it was. I said, are you going to put something square or something square? If like that's all level, I think I'm going to put laugh until I try to the next time. Okay? Then cannot eat the way, I tell you. Okay, now. Alright, next. Show that sine 90 minus theta is cosine theta. Okay, let us find out what is sine left hand side first. What is sine 90 minus theta? Oh, look up. Sine of this will be A over C, right? Am I right? Now, right hand side. What is cosine theta? A over C. Can you see they are the same? Alright. So what does this mean? I know it's the same. Sine 30 degrees will be cosine what?
Sine 30.
Yes, cosine 60, right? These two add up together. Can you see? These two add up together 90? Open here again. Okay, can you key see if it's correct? Sine 30 is cosine 60. Everybody okay?
Yeah.
Now, actually, it's quite common. Just not because I told you the triangle, just the other way around. Alright, just I think the opposite and the other way around. Okay? Now, last part 3. Part 3 is what? Hence. Hence means what? What's the value? What's the meaning of hence? Must use the previous part. Okay, look. So, previous part already told you okay? Cosine 20 over cosine 20 plus sine 70. Okay. Now, cosine 20, okay, you have to evaluate this. Alright? So, how? How to do this? Can someone tell me how to do this? Okay, all done. Do you agree that sine 70 is cosine 20? Do you agree that sine 70 is cosine 20?
Yeah.
Correct, huh? So can replace cosine 20 over cosine 20 plus cosine 20, right? Because I'll replace sine 70 by cosine 20, am I right? So this one become what? Cosine 20 over what? 2 cosine 20, right? Why not? Because this is like cosine 20 got 2 times. So do you agree cosine 20 can cancel off? So it's what? Half. It's just half. Everybody okay? Then so we can multiply it. Now, this one will come in handy when you do probate. Now look at page 276 now. Okay, all of you look at 276. The three relationships are given at the top down there. In general, for any pair of complementary angles, that means the two angles add up to what? 90 degrees. Okay? Sine 90 minus theta is cosine theta. Cosine 90 minus theta is sine theta. And tangent 90 minus theta is what? 1 over tangent theta. These three you must know. It's not given in the formula list. Is that clear? Okay? Alright, now next. I'm going to do example 3 now, and after that I'm going on to example 4, and we can start our exercise. Will that be okay? Okay, but I know you are tired. You saw me from 3:20 to 4:20 yesterday. Then you went home, you saw other teacher, and this morning you came to see me again. I'm a continuous teacher. Okay, until 9 o'clock. No choice, what? No choice. Is that clear? Oh, please listen to me, okay? Alright. Okay, let's take a look at example 3. Now, theta is an acute angle and cosine theta is half. Okay, theta is acute. What do you mean by acute? Less than 90, okay? Alright, find the value of 1. Cosine theta sine 90 minus theta. Okay, I want everybody to look at the box. This is very easy if you use the rule. Everybody listen?
Yes.
This one means cosine theta. Now this one means cosine theta also, right? Because sine 90 minus theta is cosine theta, am I right? So this is cosine theta times cosine theta. Am I right to say that? You look at the rule just now. Alright now. So I'll replace only but right. Now, I want to teach you something. What's cosine theta times cosine theta? It's times, not plus. So this is cosine square theta. That means it's square. But usually people will do this. Cosine theta square. But in trigo, we go right like that. You square. That means cosine square theta. That means it's just cosine theta times cosine theta. Okay? Can you all write down? This one means cosine square theta. Because hey, it's not cosine square theta square. It's not algebra. Do you understand? A very common mistake. If it's algebra, then must have cosine theta, then all cancel. So not rubbish. Let's square right. You will tell me this nonsense again. Okay. Now. No, you cannot type in square right. What you do is that you put in cosine square. So it's half square. Can you see it now? Cosine theta is half. Okay, wait. Can you let me finish this one? So this is a 1 over 4. Why? You must know this because later on you cannot write like that. If cosine cube, how? Write 3 times now. Or you can do it this way. Half times half. Also can. The answer is still 1 quarter. It doesn't matter. But I want to get used to this notation. Would that be okay? Alright, so cosine square theta. But if you use cosine theta times cosine theta is also okay. It doesn't matter. Okay? Now, next. Can we look at part 2? 2 tangent theta plus tangent 90 minus theta. Okay. Now, I want you to look at this. Tangent 90 minus theta is 1 over tangent theta, correct?
Yes.
The formula same okay? So this one is equivalent to 2 tangent theta plus 1 over tangent theta, right? Is everyone okay?
Yes.
Yes, okay, now. So, how? I No, we are not going to die. Cosine theta is half. And theta is acute. That means this is theta, right? Acute angle. Cosine is half. That means this is 1, this is 2, right?
How you roll it?
For cancel must be 90 what? Cosine what? You must draw 90 degrees. Because you draw obtuse, so they cannot get anything. Then, congratulations, you're going to fail. You understand? Right? So 1, 2, is it okay?
Yeah.
What is here?
Square root 3.
Do you agree this side is square root 3? Everybody okay? Alright. This one wants what? Tell me. Sine, cosine, or tangent?
Tangent.
Okay. Can you tell me what is tangent theta?
1 over 3.
1 to 3 out plus. Is it 1 over root 3 or root 3 over 1? Also, if root 3 over 1 means what?
3.
Root 3, don't put back root 3 over 1. Okay. Alright, so this one will be 2 times root 3, right? Plus 1 over root 3, right? Everybody okay? But I told you, right, this is surds, cannot like that, right? So this is 2 root 3. Do you remember how to rationalize?
Times
Times, this one times what? Root 3 over root 3, actually I multiply by 1, right? So this is what?
Root 3 over 3.
Root 3 over 3. So this is what? Over 3, right? 6 root 3 plus root 3, right? So what is it? 7 root 3 over 3. Is that clear? Okay, try rationalizing. Alright? Are you all okay? So far? Okay, good. Now, next page. Look at page 2. Later I'll summarize what I've done today. Don't worry, okay? Page 277. Now, they want to tell you how to measure angles in the Cartesian plane. Cartesian plane means xy coordinates. Okay. Now, I want to say this general. Now, I want to repeat again. Hold up. This is first quadrant, second, third, fourth. Okay. Now, if the angle is here and I measure from here up, the angle is positive. How's that? For example, if I have a line here, that means it's from here all the way here. The angle is still positive. Okay. Now, when do we get a negative angle? I think I told you before. If let's say I have a line here and I from here measure here, this will be a negative angle. Okay, that means it's in this direction. Also downwards. Now, even from here to here, if I get this angle, it's also negative. Do you understand what I'm talking about here? Okay. Now, then I want to ask one question. This one, let's say, is 240 degrees. Positive, right? Because it's this direction. May I know what is this angle in negative direction? Negative what? 120. Do you agree that 240 will be in the third quadrant? Negative 120 will also be in the third quadrant. Actually, it's the same line. Do you agree? So what I mean is this. From down here, you go this way, it's called positive angle. You go this way, it's called negative angle. Do you understand? Okay, alright, now then I'm going on to one more term that is called the basic angle. This one I've done it in English, so I'm going to read it away, okay? Can you look at page 277? First part, they say anti-clockwise, positive, and then negative is clockwise, and so on. And it's called basic angle, associated acute angle, or reference angle. Now, I will not use so many rubbish, I will just use basic angle. Is that clear? Okay, now, what do you mean by basic angle? I'm going to explain again. Now, there are 4 quadrants. Okay? This is C, A, S, T, right? Remember I told you next. Okay, now, let's take a look. Everybody, please listen. This is the most important. If this one cannot get it correct, right? Then all the rest all cannot get it correct. Now, if this is 30, okay, you listen carefully, This is 30. 30. 30. You agree that all the green one means basic angle. Basic angle means it is the angle that is formed with the what? An x-axis. Correct? Okay, now look at the first one. I'm going to highlight it in red. In the first quadrant. 30 degrees. This is the basic angle. A means what, class? All positive, right? So, sine 30, cosine 30, and tangent 30 will all be positive. Am I right to say that? Okay, now I am going to do that one again. 2, 1, and this one is root 3, right? So this is 60, this is 30, right? Okay, now what is sine 30? 1 over 2, right? What is cosine 30? Root 3 over 2, right? What is tangent 30? 1 over root 3. Everybody okay? Yes, right? No problem, huh? Okay, good. Now, so sine 30 will be half. Cosine 30 will be root 3 over 2. Tangent 30 will be 1 over root 3. All positive, alright? Okay, now, look at the second one I'm going to tell you. All done. If the basic angle is still 30, basic angle means this one. That means I'm talking about this angle, right? That means it's from here all the way here, right? Agree? Now, if it's in the second quadrant, and the basic angle is 30, what is this angle? 150, right? Do you agree it's 150? Okay. Sine 150, cosine 150, and tangent 150. Now, we write down the value first. It will still be half root 3 over 2 and 1 over root 3. But this one, what is positive? Sine. So, these two are negative. Am I right? Okay, you check your computer. Can you just cosine 150? Does it give you negative? Huh? They are the same value because they have the same basic angle. I told you already, angles that have the same basic angle have the same value except the sign is different. Remember? Can or cannot?
Yeah.
Do you agree that you get this answer? Yes, huh? Okay. Now, then we go to the third quadrant. Can you tell me, if this is the basic angle, what is this whole thing? 210, right? 210, right? So I will have sine 210, cosine 210, and tangent 210. Now, it will be the same value. But what is positive? Tangent. So these two will be negative. You must know this in your head. Okay, if cannot, you write down. Alright? Now for the last one. Remember what is this whole angle? 330. So sine 330, cosine 330, and tangent 330. They must all have the same numerical value, right? But what is positive? Cosine is positive, so these two are negative. This is the meaning of basic angle. Understand? Are we saying next meaning? I'll repeat. Angles that have the same basic angle will have the same numerical value, except the sign will change depending on which quadrant we are at. Is that clear? And this is called CAST. Everybody clear? Okay, good. Now I'm going on to the last example. Example 4. Okay? Example 4. And I want you to look at it carefully, okay? Given that theta is between 0 and 360 degrees, and the basic angle for theta is 40 degrees. Find the value of theta if it lies, first one, in the third quadrant. Part 2. The first quadrant. Now, these questions will never come up in the exam. Okay, it's too simple already. Okay. Now, let me take a look. Now, look. Theta is the whole thing, right? Until 360. That means theta can be from here all the way until here, right? All the four quadrants. So it's CAST. Okay. They said the angle if it's at the third quadrant. Now, where's the third quadrant? Here, right? That means if the angle is here, what is this? 220, right? Because, so this one will be 220. I don't want to explain. You know what I'm talking about, right? Just I explain it. Okay? Now, what if it's in the fourth quadrant? 320. How do you get 320? 360 minus 40. This is the meaning of basic angle. Is everyone clear with what I'm talking about?
Yeah.
Okay, very good.
Very good.
So that's for this part. Okay. Now, I want you to try some questions in your notebook. That will be done by Monday. And I want to start with the full step paper work with you. Would that be okay? Alright, now let's take a look. Yes, today got 2.
Okay.
Okay? Not every day, don't have all. Now, you try in your notebook question 2, 3, 4, 5, 6. Exercise 11.1. Now, may I know what's the number on the content page now of your Amex? It must be 30 something. It must be 30 something. Don't know. 33, yeah? Wow, today's cake very good, right? A lot of 7, what? If it's 7, wow. I think I won't give you anything. Alright, if it's 77, then it's plus another 16 years old, or I will want to go 8. I don't want to lose so long. You know, very scary one. Old already, cannot walk, then here pain, there pain, everywhere pain, right? Oh my god, my head, right? Here pain, there pain, everywhere pain. I don't want. I think only so long, just enough to do that. Just write trig ratios. Now, on full scale, you are going to do 7, 8, 9, 10, 12. I'm going to start 7 together with you. That be okay? Don't put this one. Don't put this one. Oh? No, put Monday I'll go through, understand? Okay? Now, in our full scale, we'll start question 7 straight away. Can you just draw that picture for me first? Don't need to be accurate, just draw. Actually, this 7 is quite simple. I just tell you how to do that. Now, this is called a projectile. You know that if you fire something, it will go with a quadratic curve. Come now. That's why volleyball people, when you smash the ball across, don't do it a projectile. The person can sure catch one. That's why when your ball go over, I see it's a projectile, right? I don't die already. If you want to smash over, right? Let me tell you volleyball people. Last time my class got a lot of volleyball people. I always ESA volleyball all in my class. Okay, what happens is that when they go for competition, I'll tell them positive and negative gradient. That's what you must see. If you are this way, right, you jump up, you must smash negative gradient. The person die already. Okay, if you stand here, you must smash positive gradient. You don't smash like that. This person will okay? Oh, projectile. So what's one of the story? What the one people? Jump high, look at the black spot, smash them to death. And if you think cannot smash right, come in, I'll just go to school in the same. The projectile is fired vertically upwards from ground level. If friction is ignored, the horizontal distance r meters traveled by the projectile is given by this issue. Okay? Please write properly. 2v naught square. That means v subscript is the original velocity. Okay? Now, sine theta cosine theta, where v naught is the initial velocity of the projectile, g is the acceleration due to gravity, and theta is the initial angle of projection. Alright, without using a calculator, find the value of r if. Now, I'm just going to tell you this. 2v naught square over g sine theta cosine theta. Now, part A, v naught is what? Tan square over g is also tan. Then sine 30 cosine 30, right? Now, you know how to get the exact on sine 30 cosine 30, correct? Plug in the value. I want the exact answer. Is that understood? Yes or no?
Yes.
Yes, okay. Likewise for part 2.